So a piece of equipment was being rated at 0.1 inches when they did the test and they were doing their ratings. That was not real world. When we got out into the field, a half inch is what, or more is what we usually find in the field when they actually got installed. And so they changed it in January 1st, 2023 to a half inch that they rate these equipment now. They rate it at real world conditions most of the time, so it's more accurate. Hi, Mitch Bailey here. I want to tell you how they came about with SEER, Seasonal Energy Efficiency Ratio, and EER, Energy Efficiency Ratio, and how those benefit you by enabling you to compare two pieces of equipment. Because when I come out or anybody else to give you a quote on a piece of equipment, we're going to give you the SEER rating, and you need to understand where that comes out from and how it was derived. So any piece of equipment in the United States is rated by the Air Conditioning and Heating Refrigeration Institute, and they establish the ratings on pieces of equipment. We call it the AHRI sheet. When we print out that sheet, it has, every piece of equipment has a number that's associated with it, and we use combinations to give us certain capacities and certain efficiencies of pieces of equipment, and that enables you to, one, get tax credits, and it also qualifies for certain rebates through certain utilities. So the AHRI rating is very important. Now, SEER, Seasonal Energy Efficiency Ratio, came about. It cannot be measured in the field. It has to be done in a lab, or it has to be done on a computer model. And what it is, it takes into account the starting and stopping of the equipment. EER, Energy Efficiency Ratio, is rated when the equipment gets up to steady state run. It can be measured in the field. I can measure EER by taking the BTUs the unit makes and dividing it by the watts it consumes to make those BTUs. Now, originally, or the way they rate a piece of equipment, whenever you hear a guy say that's a 3-ton piece of equipment, they use certain criteria to rate that at 3 tons, that it makes 3 tons of cooling at this certain criteria. The criteria being that the outdoor temperature is 95 degrees, the indoor temperature is 80 degrees, the relative humidity outside is 40%, the relative humidity inside is 50%. They measure the BTUs the unit makes, divide it by the watts that it's consuming at that criteria, and that gives them the EER of the piece of equipment. That's considered the full load. Anything above that's above full load, anything below it is a partial load. To come up with SEER, they take the partial loads of the EER at 25%, at partial load of EER at 50%, partial load of EER at 75%, and then the full load at 100%. And they can then average those out, and they come up with the SEER rating. In other words, that's an average of partial loads of the piece of equipment, and that gives them the SEER. Now, the SEER is always going to be higher because when the temperature is cooler than that 95 degrees, we're going to get more BTUs out of the unit, and it's going to use less watts to make those BTUs because the air's we can absorb more heat, and we also, because it's less hot, it's going to use less watts. It's going to consume less watts to make those BTUs. If the temperature is higher than the 95 degrees, it's going to have a lower EER because it's above that, and I'm not going to get the BTUs out of it. The air is already saturated, so I won't be able to reject all that BTUs out into the system, and it's going to consume more watts to do it, and so I get a lower EER. Again, I can measure EER in the field. I cannot measure SEER in the field. However, I can take the EER I get and divide it by 0.875, and that will give me the approximate SEER, or very close to it. For example, let's say I measure the EER of a piece of equipment and it's 14. Okay? Well, if I divide that by 0.875, it comes out to 16. So the approximate SEER is 16 SEER. It's going to vary. You're not going to be 100% accurate. This, like I said, it's a laboratory and a computer model type of measurement for the SEER. I can't do that in the field. I can't do approximate loads. However, we can approximate it. Now, SEER rating, since in 1987, they had the National Appliance Energy Conservation Act, and in 1992, President Bush signed into regulation the Energy Policy Act, which that required that the minimum SEER sold in the United States be 10 SEER. And over the decades, that's been raised to today, the minimum is 14 SEER, depending on the region of the country you live, because it can change depending on where you live. You may have a higher or a lower SEER rating that you have to maintain, but that's the minimum. That's not the maximum. So that being said, the way they rated SEER, or the way they rated the EER when they measured these partial loads, they used a static pressure of 0.1 inch for the piece of equipment when they measured all this stuff. The problem with that is almost all equipment out there that's manufactured for residential is at 0.5 inches of static, so a half inch of static. That's what is static pressure? That's the amount of resistance in the ductwork and in the whole system that will determine how much airflow we can actually move through the unit, or how many watts that's actually going to consume, because it takes more energy if we got to move more air. So a piece of equipment was being rated at 0.1 inches when they did the test, and they were doing their ratings. That was not real world. When we got out into the field, a half inch is what, or more, is what we usually find in the field when they actually got installed. And so they changed it in January 1st, 2023 to a half inch that they rate these equipment now. They rate it at real world conditions most of the time, so it's more accurate, because we were installing equipment that wasn't giving the BTUs, and it wasn't producing the SEER or the EER rating because of the rating, the way they rated the equipment. These new test standards does make it more real world, but it did do a lot, because a piece of equipment prior to the new SEER rating, the new SEER 2, was rated at 16 on SEER 1. Now today it's about 15 on the SEER rating and SEER 2, because we're not getting the BTUs, the capacity. The manufacturers had to scramble because they did not make equipment that met the criteria, and they were trying to get rid of what's on the shelf, what's in stock, and get that all out there in the field, because they're not allowed to really sell it. Now, there's some caveats to that. We can put lesser efficient equipment in this region if it's a heat pump. They want us to use heat pumps in California, and they're trying to get rid of fossil fuels. And there's nothing wrong with heat pumps. I like them. They're great. You just got to make sure you size it correctly, okay? That giving you the BTs and stuff. So again, I can measure EER in the field, but I cannot measure SEER in the field. And now that we're SEER 2, it doesn't change. The calculations are still the same. It's just I measure the watts, and I measure the BTUs it's producing, and I divide it into it, and that gives me my EER, and then I can rate that piece of equipment. So I hope that explains SEER and EER for you. And if you have any questions, please put them in the comments. I'd be very happy to help answer those questions or direct you. There's going to be some links in the description to some videos, like my 18 SEER versus 15 SEER video on the cost associated with running a piece of equipment, or purchasing a higher SEER equipment because it costs more, to the lower efficiency equipment, and how long it will take to pay back that amount of money. If it doesn't pencil out, I would rather you put your money toward like ductwork, or fixing ductwork issues, or insulation, or maybe windows, or something that's really going to give you better bang for your buck, and make the house more comfortable and actually pay for itself over time. So look at that video. It's the 18 SEER versus 15 SEER. Does it save you money? You might be surprised. And please like and subscribe. Thanks for watching, and hopefully you'll see me in the next video.